This is a video for homework 5, number 14, and in this one we are given data about males and females and how they feel about a percent of income tax that individuals should pay in income tax. And the reason this one can be a little bit complicated is that it's so long. So first of all, you have to choose the correct box plot. Now you can actually create a box plot in StatCrunch to compare, and I've actually already opened my data, but I'm going to show you how I did it. You're going to click the box here, which is going to bring up your data, and then you're going to click this little box in the right-hand corner and click Open in StatCrunch, and that will open up a new tab for you that will have your data. Now, one thing I've done to make things a little bit easier, the one thing that they did is they just put gender, tax rate, gender, tax rate. We're going to be using the two columns for tax rate, and just to make it clear so that I have the correct titles and I know which box plot is which, because I'm going to put these side by side, I changed my title here by clicking. I changed it to tax rate for females, and this one I changed tax rate males, just so you can see which one is which, and that way you're not just seeing tax rate, and not knowing which one is the male box plot, which one's the female box plot. So to do this, we're going to click graph. We're going to go down to box plot, and we're going to click both columns. Now to select both columns, you're going to go ahead and shift in order to make sure that you get both. We don't actually need to click even group by because we have the two different columns that are named differently. I do want to draw my boxes horizontally, and one good thing to do is to make sure that you mark the median. The median is really that middle value in each of these box plots. So if you look at these box plots here, you can see the line in the middle of each box. That's the median, and it's going to be really helpful to know that so that you can pick the correct choice here. So then you're just going to click compute. And when you click compute, this is what you have here. I'm just going to make it a little bit bigger. And you can also kind of hover over and see that the median for the males is 10 and the median for the females is 13.5. Now, one thing that's also interesting is that the males, they have this little outlier out here. But we're looking for one where the males, they have a median of 10, and the females, they have a median of 13.5 approximately for this example, and these guys have a pretty high outlier over here around 14. So you can make these little box plots bigger by just clicking this little value here, or you can even pop it out so that you can even see it even better, and it makes it a little easier to see that. Now right away, I can say no to B and D because the males don't have an outlier over here, and here they put the outlier with the females. And these two, they both have an outlier, but now I'm going to compare medians, these values in the middle. So like I said here, my median for my males is 10, oops, and then my median for my females was 13.5. So if I look here, and I pop this one out, this one has the median of 10, but this one has a median all the way near 20. It's probably about 18, so I don't think it's going to be that one. Let me pop letter C out. If I look here, this one has a median of 10, and this one has a median of about 14. So this is why you have choice C. It says, does there appear to be a difference in the income tax rates between genders? And this is yes. Yes, because the income tax rate for females appears to have a higher median than the income tax rate for males. So here you're comparing those medians, and the females is higher than the males because it's farther to the right. Okay. Here it says, explain why a hypothesis test may be used to tell whether the mean tax rates of the two genders differ. Here you have to go ahead and you have to check off what are the conditions that you need for a hypothesis test. Now remember, if you don't want to click through the entire text, your e-text to find that, question help is a great way to go ahead and get some notes here. Remember that this view an example is almost like going to your book and reading through an example just like you would in your text. So if you're not sure, this is going to actually go through the whole problem, explaining each one. These are your conditions. If I go to letter B, these are the conditions that you need to be able to run a hypothesis test. So the samples are from simple random sampling. The samples are independent. The populations are drawn from normally distributed samples, or the sample sizes are bigger than 30. And for each sample, the sample size is no more than 5% of the population. So you're going to click off all of those. Each sample size is small relative to the size of the population, less than 5%. Each sample is obtained independently. Each sample is a simple random sample, and each sample is large. It is not that we have to have the same sample size. You can actually have two different sample sizes for each population, but those sample sizes have to be relatively small to the size of the population. Okay, next we have to go ahead and set up our hypothesis test. Now remember that your null hypothesis, H naught, is always the equal sign. Okay, so here we're picking the mean for the males equals the mean for the females. Our alternative hypothesis is that the mean for the males does not equal the mean for the females. Okay, now how do we get the rest of this? This is all going to be done with your hypothesis testing, and again, you're going to want to use StatCrunch. So let's go back to our StatLab data set. I'm going to close my box plot. We want to run a hypothesis test for the mean difference of these two samples. So we're going to go to Stat. Because we're dealing with a mean, we're going to go to T-Stats. We are going to click To Sample. Now, this is where things, you want to pay attention. We're clicking To Sample here because the samples are independent. If our samples were dependent, this would be paired data, and we want to go ahead and click Paired. But these are just two samples. They do not depend on one another. It's not like we're asking a woman and then asking her husband. They're no way related. One sample does not determine the other sample. So if that were true, we'd be doing paired, but here they are not. We're doing two independent samples. We do have the data, so we'll click with data. Our sample 1 is our tax rate for males. And again, the reason I'm picking males first is because that's what we put first in our hypothesis test here. My second one is for females, and again, this is helpful that I actually named these, otherwise you wouldn't know which one was males and which one was females. The first hypothesis is that they are equal, and that just means that their difference is going to be 0. And the other two is that they are not equal, and you would just be changing this value here if you were doing greater than or less than, but we're just doing not equal. And click Compute. And here we go. So we have our t-statistic and our p-value. I believe here we're rounding to 2 decimal places for t and 3 decimal places for p. So if you look, just a reminder for your rounding. To rounding to 2 decimal places, you look to the 2 decimal place, you look to the right. If it's 4 or below, you stay the same. If it's 5 or above, you round up. So we're going to stay the same because next to the 8 is a 1. So we'll put negative 0.88. And then in the case of your p-value, rounding to 3 decimal places, the third decimal place is the 1, but next to it is a 9. So because that's 5 or above, we're going to round that up to a 2, so 0.382. And that's what they got here. Now, here's how it goes. I always just use the p-value approach. The phrase is, if p is low, h naught must go. This means that if p is lower than alpha, your alpha value up here, which I believe they put here, yep, 0.1. If p is lower than alpha, we reject h naught. If it's not lower than alpha, we fail to reject h naught. So p here is 0.382. This is not lower than 0.1. So because p is not low, we fail to reject h naught. Now, how do I come up with the rest of this? So I'm working with either do not reject h naught, this is letter A or B. The difference here is that there is either not sufficient evidence to conclude that the mean income tax rate is different, or there is sufficient evidence to conclude that the mean tax rate is different. So in this case, we have to take a look at what our claim was, right? So if we're failing to reject h naught, right? That means that we're kind of saying, hey, you could be true, right? So that means there isn't enough evidence to conclude that the mean tax rate is different from the mean tax rate for females. We fail to reject h naught. This could be true. Okay, if we fail to reject, this could be true. We're saying, we don't know about you. If we were rejecting this, we would be accepting this. Okay, so do not reject. We can't call them guilty. So we don't know if it's true or not. There is not sufficient evidence to conclude that the mean income tax rate is different than the mean income tax rate for females. So I hope that helps. I know that this part can be a little, confusing with the appropriate conclusion. But again, take a look at what you're failing to reject or rejecting. If I were rejecting, I would be technically accepting this one.